I'm Chris Blythe with Jaws Blythe Engineers. I am out here with a couple of our engineers doing a paving evaluation for a local community. This community is approaching the 20-year-old asphalt pavement, which is roughly the expected useful life of most asphalt in a residential setting. One of the things they are concerned about is, as they're nearing that expected useful life, what is the scope of work and how many years do they have left? And because they are also doing a reserve study at the same time, they've asked for, and because of how much paving they have, they've asked us to come give them a little bit more accurate analysis of that expected useful life and what that scope of work is likely to be when they do the pavement resurfacing project. So as part of that, we core the asphalt, we measure the thickness, and what we're going to do is show you now what that process looks like. Once we finish with the coring process, we end up with asphalt cores, like you see here. And this is kind of why it's helpful to do this process to help you with that paving evaluation or that paving scope of work. And this one, we have a single 3-inch layer of asphalt. It was done in one lift, and that's fine for most pavements, you know, a single 3-inch lift. However, in the one that we just did, this one is a 4-inch layer that was in 2 lifts. You can see the line here that delineates the 2 different lifts. So if you plan on the project, and we did it for a reserve study, we're going to assume, you know, probably a 3-inch layer, but in this case they have the 4-inch. So it's going to affect how much asphalt and the cost of that, as well as how the longevity of that pavement. So once we've done with the pavement, we would then auger out all the stone that's in before we get to the soil subgrade. We auger it out with either a hand auger or a gas powered auger, and we're going to measure that thickness. So that helps us understand what the full pavement thickness or the pavement profile is, and helps us to figure out how much useful life they have. In addition, when we do the core sampling, we're actually trying to evaluate where's the best place to do it. Sometimes we're looking for cracks. If there's areas in your pavement that have a lot of cracking or fatigue cracking, alligator cracking, some bad things, we're going to go test that to see if it's the pavement is the problem, is it the stone thickness is the problem, or is the subgrade the problem? So we're evaluating all those different things. Now we're going to just take a look at what it looks like after we've removed the stone. We're going to show you what's called the Kessler Dynamic Column Penetrometer, or DCP, and that's how we evaluate that soil subgrade. So we'll look at that now. We use the DCP to evaluate the soil. And how we evaluate the soil is correlating all that information and those blow counts to the California bearing ratio, or some people like to think of it as the bearing capacity. And honestly, the soil subgrade is what gives that pavement its structure. It helps it to really reach that expected useful life like we want it to. Sometimes it doesn't hit that 20 years, and that's usually because of the soil subgrade. Once we're done with the DCP and the pavement coring, we will take all those soil cuttings and stone cuttings, put them back into the hole, recompact it as best we can, and then use what's called a cold patch or an emulsified asphalt to fill in that hole. And we'll show you what that looks like right now. Again, this is Chris Blythe with Jaws Blythe Engineers. If you've gotten some paving proposals and they are all over the board and you want a little bit more accurate scope of work, or you just want help budgeting for your future reserve study, give us a call. We're happy to help.